Hello everyone, my name is Tavleen and today I'm excited to present my project on the nutritional analysis of a food dataset. This analysis explores key nutrients, food group patterns, and insights that can help inform better dietary choices. Nutrition analysis is crucial for understanding the health value of the foods we consume. With detailed food composition data now available, we can uncover patterns, identify top nutrient sources, and make informed recommendations whether for the individuals, nutrition professionals, or the general public. The objectives of this project were to explore a diverse range of foods, identify the top sources of key vitamins and nutrients, compare nutrient profile across food groups, and assess nutrient density. I also aimed to demonstrate how effective visualizations can help communicate complex nutritional information clearly. So let's talk about the dataset source. The dataset I used came from Kaggle, combining 5 CSV files into one comprehensive dataset covering a wide range of foods. This gave me a solid foundation to explore nutrient patterns across major food groups. So, the link from which I got the dataset is mentioned over here in the second point. Dataset contents. So the dataset contains nearly 2,400 rows and 37 columns, covering both macronutrients like protein and fat, and micronutrients like vitamins A, C, D, and E. It includes foods from all the major groups: fruits, vegetables, meats, dairy, grains, seafood, and more. Okay, so this is about the sample dataset. This is how my sample dataset looks like, which has food from different groups like spinach, beef liver, cod liver oil, milk, carrots, and over on the top, every column there is mentioned like all kind of the nutrients like calories, protein, fat, carbs, all the vitamins, and sodium. Now let's talk about data quality. So what happened is, over here before analysis I ensured data quality by addressing minimal missing values, removing duplicates, and standardizing nutrient values per 100 grams of edible portion. So generally I did not get any kind of missing values on this data set, just two duplicate values over here which can be explained through the which can be explained through unnamed column, and it hardly has nothing, no value. It seems like it's a redundant, so it can be removed. So and then we took in regards of all the of the consistency, where all nutrients values were standardized as per 100 grams edible portion. So now we will head to visualizations, where I'll show some insightful data that we have got from all the or like from different data analysis. So let's dive into the first visualization, which is food group distribution. This pie chart provides a quick overview of the dataset's composition, showing which food groups are most represented and how balanced the data is. So in this pie chart we see that every food group is categorized into different percentages. So this means like this that is the composition of most of the foods which is present in the data. And over here we see other category has the maximum the maximum percentage. That means this could be out of all the standard food groups. It could be the all of them, and we will be able to check that further in our further analysis. So now we will talk about top 10 foods by nutrition density. Here we see the most nutrient dense foods, which tend to be minimally processed items like certain cheeses, seeds, nuts, and animal products. Interestingly, the cherry juice, which is known as acerola cherry juice, tops the list, highlighting the power of plant based nutrient density. So, now we will talk about average caloric value. This graph shows that meat and poultry products have the highest average caloric value, followed by seafood. Interestingly, pure fats don't appear as the highest, likely because the dataset includes lean cuts or containing items with waters or other components. So generally, so it basically contradicts our standard nutritional understanding that pure fats contain highest calorie, but it doesn't seem like on the graph. It seems like meat and poultry has come up to be the highest, and this shows the major data discrepancy. So this discrepancy could be because the dataset might include many lower calorie items within each category. For example, the lean meats, or in the meat and poultry category. The fats and oils category might include products with significant water content or other non-fat components. Now we will talk about average sodium content by food group. This line plot, this kind of a line plot highlights which food groups are typically high or low in sodium. As expected, processed foods and cheeses are high, while fresh fruits, vegetables, and fats and oils are naturally low. Now it's all about the correlation matrix of selected nutrients. This heat map uncovers basically the relationship between nutrients, such as the strong correlation between fat and calories, or the potential inverse relationship between vitamin C and sodium, insights that can guide dietary recommendation. So basically, we see fat has the highest relation with the caloric value, and sodium has the least ones. Now we will talk about the word cloud. So basically, this word cloud provides insights into what we eat and how it's prepared. Preparation methods like cooked or fried, major categories like beef and cheese, and processing levels like canned or raw all influence nutritional professionals. So this word cloud also shows that these cooking preparation methods like cooked, raw, roasted, fried, it suggests that how food is prepared affects its nutritional profile. So it also shows the prominence of the canned and the raw, which indicates that the state of food, which is processed or fresh. So it is also to be taken in consideration, as it is an important nutritional consideration. Now we will talk about different proteins versus carbohydrates for food groups. This plot makes it easy to compare food groups. Meats and seafood are rich in protein. Grains and fruits are higher in carbs, while dairy and vegetables sit somewhere in between. This helps guide the choices for specific dietary goals. So in this slide, which says top foods based on vitamins, so I tried to provide the insight related to all the vitamins and show what foods are kind of highest in the category of a particular vitamin. For example, in this first graph, which is vitamin A, we see that dessert wine dry is the highest source of vitamin A in this data set, followed by beans cooked, and then white wine. And basically we see all sorts of wine show that they are higher in vitamin A. Then let's come to vitamin B. So I had a data of various vitamin D, like vitamin B, like vitamin B1, vitamin B2, and so on, which made it complex to plot the graph. So I combined all of the complex vitamins and plotted it according to the different food groups. And over here we see that the high protein creamy chocolate slim fast is the highest among all kind of vitamin B's, followed by fruit nuts, then pork, and then all sorts of meat and like pork and turkey. Then to continue, we see that like these are categorized by vitamin C, vitamin D, and vitamin E. And this information is just essential for ensuring a balanced diet and meeting micronutrient needs. In vitamin C, we see acerola, cherry juice is the highest. In vitamin D, we see pokeberry shoot straw, and then in vitamin E, we see major kind of oils that are rich in vitamin E. Okay, let's come to the conclusion. In summary, we identified top foods for various nutrients, uncovered the clear patterns by food group, and even noted surprising results like unusual top caloric sources. These findings emphasize the importance of a varied diet and can inform better menu planning and public health guidance. So we do also see the practical implications that this project can be used for basically meeting the vitamin various vitamin needs, and also used for public health recommendations as well. Last but not the least, this slide mentions about all the recommendations and the next steps that can be taken after this kind of an insight. So looking ahead, we can focus on key food groups to address nutrient gaps, recommend supplements where needed, and personalize nutrient advice. Future steps could include using machine learning to predict nutrient gaps, clustering dietary patterns, or even developing a nutrition scoring system. So these three steps can be implemented next to just diversify between different nutrients, different food groups, and I think data modeling can definitely help with proper understanding of this project. Alright, so thank you for watching my presentation. I hope these insights sparked your curiosity about nutrition data and its potential to improve dietary decisions. I'm happy to take any questions or discuss further. Thank you so much.